lecture series, we've been seeing um engineering graphics basics, some fundamentals of that. So we started with position of points, and then we moved on towards position of lines. Now we will move on to position of solids. So solid is a three-dimensional object. We know that. So three-dimensional object will have length, breadth. So basically, it will have an area and also a z-axis projection. So in most objects we have length, breadth and also thickness or height. So it is completely bounded by a surface or surfaces which may be curved or plane. So when you draw the orthographic views, it will be with respect to horizontal plane and vertical plane. We need to draw the first the predominant ones we need to draw are the front view and top view with respect to the principal planes HP and VP. So there are we'll segregate the types of solids into two types. One is type A and type B. Type A is polyhedra, and type B will be solids of revolution. So polyhedra, these are like uh, solid objects that are bounded by planes or faces. So remember that you had like for a cube we have the faces, right? Uh, So we have the one, two, three, four phases up and down. So we have six phases, right? So each phase will be all these type of solids will have these sort of like phases. So these sort of phases with which meet at the edges, uh, these sort of objects will be called polyhedra. For example, we have tetrahedron, cube, octahedron, icosahedron, like pentahedron, and so on, hexahedron, hexagon, and so on. So under polyhedra, we have two types. One is prism, and the other is pyramids. So we'll start off with prisms. So prisms, these are solids which have the top and base shape will be the same. Say for example here in this one we have triangle is this the base shape, and also the top shape will also be the same. It will be the same, and the dimension also will be the same. So similarly we have for square we have here the face is same, and here also it is the same. Similarly we have pentagon and hexagon. So these sort of shapes we will call it as based on the base shape. So here this is triangular in shape. So this object is called triangular prism. This is called square prism. So a square prism is nothing but a cuboid. Similarly, pentagonal prism and hexagonal prism and so on. So for example, obviously we have the cuboid. For cuboid, we can have like any object that is, let's say for example, we can have a brick. Let's consider a brick. So the bricks top and bottom surfaces are the same shape. So and it is elongated. So this is the brick will be an example of a rectangular prism. So what you can do is you can comment in in the comment section some examples of prisms. Mention the type of prism, that is square prism or pentagonal prism or whatever it is, and then write the name of that particular object, everyday day-to-day objects. The pyramids are ones that have the edges joined together to at a point on the top. So you can see the edges here, right? The edges of the triangle, they are meeting at the top from the center. So this top we will call it as an apex. So if the objects, the edges, they are connected together at the point at the center, and this is a point center called apex. These sort of objects will be called pyramids. So this is a triangular pyramid, square pyramid, pentagonal pyramid, and hexagonal pyramid. So easy method to understand if it is a prism or pyramid is nothing but remember the pyramids, great pyramids of Giza. So the pyramids have a sort of a, uh, I mean, the geometry which joins at the top, right? So The Great Pyramid of Giza might be a rectangular pyramid. So we don't know what the base shape exactly is. So I don't know exactly what shape it is. So for now, I'll consider it as a rectangular pyramid. So give me examples of pyramids. Okay. So put them in the comment section as well. So considering a polyhedra, we have square prism and pyramid. We have a prism and pyramid. So for prism, we have the base and this will be the tops. So both this base and top, they are of the same dimensions and they are the same. So the corners of the base, so these are the corners and these are the edges. So this is the longer edge and this will be the shorter edge. So we have the rectangular face and this if you consider the center, it is the axis. So this is the top and this is the bottom. When we come to this part, the pyramid, square pyramid, we have the base, same as this. We have the same base, the corners, the edges, and the base. But what changes here is that we have apex, and in the center, let's say from the center of our base, if we draw a line, that it will meet at the axis. So all of these will converge towards the axis. So the edge will slant. So here the edge, they are perpendicular to the base. Here they angle towards the axis. So from this edge it moves on towards the apex. Similarly from all the edges it moves to the apex. So each face will be triangular face. So here it is rectangular face, but here it will also always be triangular faces. Next is solids of revolution. So when a solid is generated by revolutions of a plane figure about a fixed line or a fixed axis, then these solids are called solids of revolution. Let's say, for example, if you have a circle, um, so what happens is when we revolve it around this axis, so we get this thing. We'll get the cylinder. Similarly, for cone also, let's say if we have this part from the, so let's take one of the slanting lines, and also we assume that there is a axis in center. What happens is if we revolve it, uh, it forms a cone. Here it might be let's say a C sort of shape, but a C with the rectangular edges or straight edges. Then it will form the cylinder. If it is slanted and it is revolved, then it becomes a cone. If it is revolved around, let's say if we have a circle and you revolve it, then it becomes a sphere. So in solids of revolution, we have the base and we have the top. So for cylinder is nothing but a circular prism when you compare to the previous part, and cone will be a circular pyramid. So similarly, we have axis that is at the center. So we make some generators to, so we don't have edges, right? So we need to make imaginary edges so that it can be, it will help us to draw the uh, draw these diagrams. So these imaginary generators will be the edges which will, here it will be perpendicular to the base, and here they will be slanting towards the apex and connect to the apex part. So the imaginary lines, they will be used to generate the curved surface of cylinder and cone. So give us examples of both cylinder and cone in real life scenario. Thank you.